Now let's use the property of connecting the size of the angle and the length of the side to a triangle ABC. So let's take inequalities in a triangle as the topic connected with triangles in the session. Inequalities in a triangle. So let's see how we can connect inequalities in a triangle. Imagine I have a triangle out here. Then let's take the case of the triangle ABC. Now clearly I can see that angle A is smaller than angle B, which is obtuse, and thus being acute. Therefore, the property here says that the side smaller the angle, smaller is its length of side. Larger the angle, larger is the length of its side. Therefore, this being a smaller angle, BC is the smaller side, and angle B being the biggest or the obtuse, AC is very long. Smaller the angle, smaller is its opposite side. And similarly, larger the angle, larger is its opposite side. Therefore, in the triangle ABC, I find that angle A is less than angle B. Implies smaller the angle, smaller is its opposite side. Therefore, the opposite side of A, which is BC, must be, the length of BC must be shorter than the length of AC. Is how I understand the property connecting the angle of a triangle and the sides opposite to the angles. Smaller the angle, smaller is its side. So the property finally concludes that the angle opposite to the smaller angle is the smallest side in a triangle, or the side opposite to the smaller angle is the smallest side in the triangle, or the side opposite to the largest angle is the largest side of the triangle. Is how we connect the property. Connecting smaller the angle, smaller is its opposite side. Larger the angle, larger is its opposite side. Is how we understand the concept connected. Inequality in a triangle. Now let's see a property which connects the sides of the triangle, the three sides of the triangle. Imagine I have a triangle A, B, and C. ABC is a triangle in which the three sides are AB, BC, and AC. So what is the property which connects all the three sides in a triangle? This property is one of the most important property in the inequality properties in a triangle. So let's see the property connecting the three sides of a triangle. For this triangle ABC, there are three sides which are AB, next is BC, and then the next is AC. So AB, BC, and AC are the three sides of the triangle. So using these three sides, let's see how the geometrical property connects. It clearly says that suppose I want to take BC and I want to take sum of the other two sides AB plus BC. Then how do I relate the three sides AB, BC and EC when the sum of two sides AB and BC are connected with the third side AC? Mathematically, the property says that the sum of two sides will always be greater than the third side. This may be true if you take BC and AB or BC and AC. That is, AB plus AC will always be greater than BC. So if I take the two sides AB and AC, then the sum of these two sides must be greater than the third side BC. Next, if I take the two sides BC and AC, AC plus BC must be greater than AB, is how I see the properties connected with this. Is how we understand the sides connected with inequality. So this is called triangle inequality. Inequality which states that sum of two sides of a triangle exceeds the third side, or exceeds is always greater than the third side. Therefore, sum of two sides of a triangle always exceeds the third side, is how I connect the triangle inequality in the triangle ABC. Sum of two sides exceeds the third side. Triangle inequality. AB plus BC greater than AC, or AB plus AC greater than BC. AC plus BC greater than AB. That's how we see the triangle inequality. Now that we have seen the triangle inequality, will the inequality be true if it is equal? Let's see the investigation of triangle inequality reduced to equality. So for example, I have a triangle A, B, C. Will sum of two sides be equal to the third side? Is how we see. Clearly, I can see that when I take AB and BC, when I add the two sides, then obviously it must be greater than but can never even be equal to AC, the third side. Because for a triangle, a closed three-sided figure to be formed, we need to have the condition that when you add two sides of a triangle, its third side must be less, cannot be equal or greater than. Therefore, when this is strictly greater than is how I understood. Therefore, AB plus BC, it is important to note that AB plus BC, it can never be equal to AC. It should be strictly greater than. Therefore, my learning outcome out here is that sum of two sides of a triangle can never be equal to the third side, because in that case it cannot get a closed three-sided triangle, because it fails the condition of forming a closed three-sided figure, that is the triangle. It fails the condition of forming a closed three-sided figure, or it form an open triangle, is how we understand the strictly greater than concept connected with sum of two sides always exceeds the third side. At the most, it cannot be even equal to or less than. Is how we understand the triangle inequality strictly following the strictly greater than inequality. Is how we connect the triangle properties with inequality.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.